Hey everyone, so today we will see the third type or the third method you can say to solve the problems on surface integrals. So suppose if you have a scalar field and you have a function, if you have a surface where you can explicitly represent your z as a function of xy. So the previous case was a scalar field and a parametrized surface. So if you have a scalar field, even you can parameterize this and you can apply the second method. But if you are able to express your z explicitly in terms of x and y, so where this is a function of x and y, then you can use the formula directly, which I will state over here. No need to go into the world of u and v. You can stay into the world of x and y and you can solve the problem. And how can you do that? So let's see that. Before that, can you always do such thing? Answer is no. Suppose if I give you a sphere, x square plus y square plus z square equal to 1. Can you write it in this way? No, because from here what you have? Z equal to plus minus 1 minus x square minus y square. You can't say let this be f of xy because your function can't take two values. What is a function? For every input you have a unique value. So you cannot have plus minus. So for this you can't do. But suppose if you have a plane 2x plus y minus z equal to 3, then here you can say okay, z is 2x plus y minus 3. So this is my f of xy. If you have such a kind of thing where you can express your z, or say z equal to x square plus y square, or say 3x plus y x plus z equal to 0, then here you can express your z equal to function of xy, and in these scenarios you can use this method or the formula directly. So let's see what kind of formula it is there to solve this kind of problems. So let's go by the previous way itself. Let's try to parameterize the surface. So we know that by previous method, if you have a surface and g of r dA, g is a scalar field, then this is equal to r into what you have here, g of r of uv in mod of n du dv, right? And here this is without regard of orientation. But yeah, if someone says let n be the pointed upward, then we put the plus sign, and if someone says let n be pointing downward, then we take the minus sign. These are the orientation some people follow, so you can keep that in mind. Okay, now let's come to this. So how you will parameterize? You call x equal to u, y equal to v, and then what will be my z? So if I put x equal to u, y equal to v, my z will be what? F of uv, because x is u, y is v. Now what is my normal vector? You write down here I, j, k, and what is f with r with respect to u? 1, 0, f with respect to u. R with respect to will be 0, 1, f with respect to v. And what is this? I into minus f with respect to u minus j into f with respect to v plus k into 0. So what is mod of normal vector? Sorry, k into 1. So what is this? It is 1 plus f with respect to u square plus f with respect to v square. This is what your mod of normal vector is. If you can put it over here, so what do you get? So if I put that value over there, so what do we have is double integration r g of r of uv into square root of 1 plus f with respect to u square plus f with respect to v square du dv. But what is your x? Your x is nothing but u, and what is your y? Y is nothing but v. So your f with respect to x is same as f with respect to v, and f with respect to y is same as f with respect to v. Where z is nothing but f of xy. So because of this thing, your surface integral is g of r dA is nothing but, you can write this as, let me call this as r star. I will tell you what is this. This is g of, instead of now r, now I won't bring parametrization into picture. I have x comma y. Wherever I have z, I will replace my z by f of xy. So this will be something in terms of x and y only, into mod n. What is mod n? 1 plus f with respect to x square plus f with respect to y square dx dy or dy dx. What is r star? It is the projection of the surface in xy plane. You see what is the projection of the surface in xy plane, that is your r star, and according to that projection you find the limits. Okay, and regarding n, I told you positive negative. If n is pointing up, you take positive. If n is pointing down, you take negative. That's the orientation people follow for this kind of thing, scalar field. Okay, so yeah, so that's what the third method is. Well, it's irrelevant if you want to use the second method itself. You can always use the second method. This formula also we have derived by using the second method itself, the previous one. But yeah, sometimes people directly use the formula, and this is many times easier. So you can use this formula directly to solve such kind of problems. So now let me take some examples so that this will be clear to you. So we have done this problem in my previous lecture using the parametrization thing. But now let's do this using this formula. Okay, so what to do is the first thing is you write your z in terms of x and y. So here, now what is your f of xy? It is nothing but 2 minus x minus y. You find f with respect to x, which is 1 minus 1, f with respect to y, which is minus 1. So what is mod of n? It is square root of 1 plus this square plus this square. So 1 plus 1, which is root of 3. Okay, and what is your g of x comma y comma f of xy? So this is nothing but there is no z over here, so this is the same thing. It is cos of y plus sin x. So therefore, by the formula which we just wrote over here, s g of r, or you can say g into dA, this is nothing but double integration over r star. So what is the projection? You have a plane, so what is the projection of this plane in xy plane? It is this 2, 2, this is x plus y equal to 2. You put z equal to 0, you get this line. Okay, so what is the limits of y? My y will go from 0, the same multiple integration that you have studied. So y will go from 0 to 2 minus x, and x will go from 0 to 2. I have cos y plus sin x, root 3 will come outside, and I have dy dx. You solve this and now you will tell me the answer. I am not going to do this. So simply solve this and tell me what answer you are getting. This should be the same answer as you got in my previous lecture. Okay, I think even there also I solved this much and I gave you the homework. So yeah, answer has to come out to be same. So your first homework is you pause the video right now, solve this problem. Yeah, because afterwards you are not going to solve it. So simply pause it and tell me the answer over here. So here is the second problem. I have written most of the things just to save your time. So this is a scalar field, this is a surface, and here they have directly given you the limits of x and y. See, so they have reduced your job a lot. So here from again, can you write your z in terms of x and y? Yes, you can. So z is x plus 2y. So this is my f of xy. Find f with respect to x, 1, f with respect to y. Find the mod of normal vector, which is nothing but 1 plus 1 square plus 2 square, so root 6. Find g of xy, f of xy. So you keep xy as it is. Wherever you have z, you replace your z by this f of xy. So x plus y plus, what is my z? X plus 2y. So you have 2x plus 3y. And therefore again by the formula, integral of g, surface integral of g is nothing but 2x plus 3y into mod n, which is root 6. So root 6 will come outside, and here you have dy dx. And now this is a normal double integration, right? So you simply solve this double integration, and this is the second homework. You have to tell me what answer you are getting. So as you can see, once you have such kind of thing, then your calculations, I mean, you can really save your time. No need to write r of uv, then find the normal vector and all. You directly use the formula and you get the answer. So this is the third type of problem, or the third way you can tackle a surface integral problem. So now let me give you one last homework problem for your practice. So here is a homework problem. Again, why I have written over 3? Because first 2 also you have to tell me the answer, and this you have to solve completely. So your z is xy. Okay, so here, I mean, from first to example, you should not conclude that your mod of n is always a number. We got root 3 and root 6 if I am not wrong. Here you will get something in terms of x and y. Okay, so that's why I am giving you this as a homework, so that you should know that your mod of n need not be constant always. Okay, so yeah, now you just try to solve this problem and answer me this in the comment section. So you are supposed to answer 3 questions. So yeah, if you understood this, then yes, do not forget to like, share and subscribe. And if you have any other doubt, then you can also ask me in the comment section. Thank you.